Okay, on like the worksheet, it won't say increase or it'll say increase or decrease because they don't want to give it away. Okay, you gotta choose which one it is, but we're doing increase. Okay, so since it's growth, the equation is y equals a times 1 plus r. Okay, the one we just did was 1 minus r because it was decay. You gotta pay attention to which equation you're using. Right, so growth is 1 plus r. So the way that we found this question on number 7 was we did 1 plus r equals 1.99. Okay, parentheses equals parentheses. Okay, then we solve for r. So it's easier with the growth. It's easier to see what it is. Okay, so we solve for r. How do we solve for r? Minus 1. $1.99 minus 1? 0.99. So what's the percentage? 99%. 99% increase. Okay, and this one's easy to see because you just know that it's what's above 1. Right? With the growth, it's easier to see because, again, we can see 0.99 right there. All right, C, original number of bacteria. All right, what letter is that in the problem? A, right? Is it 100? Yeah. All right, read the whole problem again and double check. Yeah. Read the whole problem again and double check. Read the whole problem. What does it say? In thousands. Okay, in thousands. That means that 100 is 100,000. Okay, 100,000. And the reason that we do that is because if you put 100,000 in the calculator, you'll see, I'll show you in just a second, it doesn't fit in the table very good. So it's easier to just do 100, do a smaller number. All right, okay. 2 more questions just like we did. How many bacteria after 7 hours and how long until it reaches 1 million bacteria? How many bacteria will there be after 7 hours? And how long until it reaches 1 million bacteria? So, what do we need to do? Put it in y equals. This is what we did last time, right? So I'm going to put the original equation, just 100 times parentheses 1.99 to the x power. And then we look at the table. All right, go ahead and everybody do this. I want to make sure you know how to do it on your own. Then look at the table. All right. Hold tight. 7 hours. It tells me this. 12,359, right? But what do we know about this number? It's in thousands, so we need to add 3 zeros on the end. All right, so it's 12 million. All right. So that means that to get 1 million, it's going to be less than 7 hours, right? We need to go up until we just see 1. Right now, like I said, it's not going to be exact. Okay, where does it go to 1 million? I would say 3 is at 788,000, right? 4 is at 1.5. So that's 1,568,000. I would say between 3 and 4 hours. Okay. It's because it's always going to be a little bit, it's never going to be like precise. If I do this on a test, I'll make it real obvious. Okay. I will not put like 3 hours and 4 hours as the two choices because neither of them is really 1 million. I will make it to where it's very obvious. And also this is like, I guess it's a little closer to 3 hours, but it's really right in the middle. Okay. If it's closer to one of them, choose that one. Okay. But either way, if you get close enough, I'll give it to you. But you got to watch out on the ones where it says in thousands, because then it just doesn't have enough, because there's just not enough space for a million zeros. You know what I mean? It'll run out. Any questions? All right, last one. Let's finish this before our little send-off. Okay, this one only has 3 parts, so it's a little bit easier. Okay, number 9. The deer population in a park grows by 7% each year. The deer population in a park grows by 7% each year. If the population